Okay, so another thing that we start doing when we do natural logs is we start looking for patterns so that we can use natural log to do antiderivatives. So for example 5, so you've got cosine of t over 1 plus sine of t dt. So you can go through the whole u substitution, but if you just look, the derivative of sine of t is cosine of t, the derivative of 1 is 0, so that goes away. So you have u and u prime. So that rule with the chain rule with log says that this would be the natural log of 1 plus sine of t plus c, because its derivative is up there. It's just u over u prime. Okay? So another example we need to go through. Now, if we were taking the normal AP exam, they added long division into it. So I don't know if long division is going to be on this free response or not, but we'll see. So for this one, they've given you the integral of x squared minus 3x plus 2 over x plus 1 dx. So we're going to talk about doing long division to simplify it, and then how that leads to natural log. So if we do long division, we have x plus 1 being divided into x squared minus 3x plus 2. So x times x gives you x squared, and then you bring that down, so then x times 1 gives you x. So x squared minus x squared goes away. Negative 3x minus x is negative 4x. Bring down that 2. So you have to do x times negative 4 to get negative 4x. Negative 4 times 1 is negative 4. Subtract those, so this cancels out. 2, and then a negative, negative make a positive, so 2 plus 4 is 6. So you have a remainder of 6, so 6 over x plus 1 is your next part. Alright, so that means that this whole rational function could be written as x minus 4 plus 6 over x plus 1. So we can break this apart into different integrals. So I just did 2. You could do 3 different ones if you wanted to, but I only did 2 of them. So I kept the x minus 4 together, and then did 6 over x plus 1. So the antiderivative of x is x squared over 2. Antiderivative of negative 4 is negative 4x. Then you can take the 6 outside of your integral because it's just a numerical coefficient. So you have 6 out here, then you have 1 over x plus 1. So you're bringing all this down. If you look, the derivative of x would just be 1, so this is kind of like what example 5 is. So you automatically should just know this is a natural log problem. So you take the antiderivative of this, it would be the natural log of x plus 1. And then make sure you put that plus c on the end to take care of all the constants for this problem, and it's because it's a general antiderivative. Alright, and then let's look at another trig example because I know you all love trig so much. So if we took the antiderivative of cotangent of x. So what we're going to do is you're going to start rewriting these if you can. So you're going to rewrite cotangent to be cosine over sine. Alright, so sine is your u, cosine is your du. So if you notice it's u over u prime, so that should automatically tell you it's going to be 1 over u du, so it's going to be a natural log, okay? So if you have u du, natural log is your answer, okay? So the antiderivative would be the natural log of u plus c, and so it's going to be the natural log of sine of x plus c, okay? On page 333 in your book is where all of the antiderivatives of the trig functions are. So you need to write those down and get familiar with those, and since you get to have notes on the AP exam, I would just make sure I have all this written down somewhere. But this is one of them, and then you already know cosine and sine, but then the other ones you need to look at.